So we are going to start by measuring out our mass of our two reactants, copper sulfate and iron. So we've got our balance. It's level here on the balance itself. And I am going to put a weighing container, this is called a weigh boat, onto the balance. And I'm not going to bother recording that mass. I am just going to tare it. I just press the tare button and it re-zeros the balance with that weigh boat on it. And now I'm going to measure out our copper 2 sulfate. So this is copper 2 sulfate pentahydrate. Okay. So copper 2 sulfate pentahydrate, that's CuSO4.5H2O. What this means is that within this copper sulfate crystal, it's made up of copper ions and sulfate polyatomic ions. Trapped in a very regular proportion within that crystal are 5 water molecules. When you calculate the molar mass of this, the formula mass, you actually have to add in the mass of 5 water molecules in addition to the copper sulfate, because those water molecules are going to account for a portion of the mass that I'm going to measure out on this balance. So my directions tell me to measure out 6 grams and record the exact mass in our notebook. Okay. And this does not have to be exactly 6. I'm trying to get there, but I'm not going to get it exactly, I'm sure. We'll get just a little bit more. Oh, okay. So that's pretty good. Now I'm going to record that mass here on my data sheet, the exact mass that I measured out. And next, I'm going to take a new weigh boat and measure out my iron. Okay, that actually turned out to be about the same mass as the other weigh boat, gave me a 0. I'm just going to tare again just to make sure. Okay. Now, the iron that I'm going to be using is actually coming in the form of steel wool. We want to make sure that we don't get too much iron in there. It can be a real issue. In terms of this reaction, if it's there's too much steel wool in there, it's not able to interact fully with the copper sulfate. So we want a maximum, of 1 gram. So I'm just going to do a little bit at a time, just so I get a good sense of what that is. This is very fine. Breaking it up as I do it is probably a good idea for this reaction. Just do a little bit more. That's good enough. Okay, so my other reactant is my iron, and that's going to be equal to 0.67 grams. Now, in this reaction, the copper 2 sulfate and the iron have to chemically react with each other. And as two solids, it's really not very likely to happen. So we need to get them into a medium in which they can more easily react. So what we're going to do is we're going to take our ionic compound, copper 2 sulfate, and dissolve it in water. So here I have a 150 milliliter beaker. I'm just going to take my whey boat, pour my copper 2 sulfate in. Now the exact volume of water that I dissolve it in is not going to matter. It's just the medium in which the reaction actually takes place. It's the amount of copper 2 sulfate that we've already recorded in terms of our mass here that matters. So I can just sort of eyeball, we're going to do about 50 mils. I'm actually going to, just to make sure I get all that copper 2 sulfate, I'm going to take my water. This is a squeeze bottle of distilled water. And I'm going to rinse the sides of my whey boat just to make sure I get all of it out and in there. All right. Let me just add a little bit more here. All right, so that's probably about enough. What we're going to do to help this actually dissolve is we are going to heat it. So we're going to put it on our hot plate and heat it up. Now we're going to try not to allow this to boil. I really don't want it to splatter on me. We are just going to heat and stir until the crystals, the blue crystals, actually dissolve. So now I've got my fully dissolved copper sulfate in my blue solution here. I am just going to get the reaction started by adding my steel wool, my iron, that I've measured out the mass for. I'm going to do the best I can to get as much of this in here. There's a little bit of iron left on the side. We're just going to push that down in here, stir it around a little bit. And I'm going to come back and stir every once in a while. But we're just going to let this sit for 10 minutes and just react away. Okay, so while we are waiting for that to finish reacting, I've gone ahead and set up our filtration apparatus. So once this is done reacting, we are going to filter out the solids and allow the solution to actually go through. Okay? Now, to do that filtration, we're going to use what's known as gravity filtration. The particular technique known as gravity filtration. And so this is just very simple. I'm going to see if I can move this a little bit closer to you guys so that you can fully see this setup. So this is a ring stand back in the back, and I've actually attached to it, I'll bring it down a little bit so you can see, an iron ring. I'm going to raise it up because I'm using this solely as a support for my funnel, right? This is just a funnel. It's a simple glass funnel for the laboratory. We're going to place it right there in that iron ring, and underneath it we're going to put a beaker to capture any liquid that goes through. We are also going to take some filter paper. Let's see, where did I leave my filter paper? There it is. We're going to take some filter paper and actually fold it up and put it into that funnel to capture any of the solids. Okay, so here's our filter paper. Then we'll take the solids, we'll allow them to dry. We're just going to leave them here in the lab overnight and let those dry, and then come back the next day when they're completely dry and take the mass of those again, and then we'll get the mass of one of our products, our solid product. Now, because those solids will be dried onto this filter paper, it's really important that you also get the mass of the filter paper. You're not going to be able to separate the two, at least easily, without leaving some of the solids behind on this. So it's just better to go ahead and take the mass of this, so that when you put this and the dried solids together, you can just subtract out that mass at the end. Okay, so I'm going to let that continue reacting just a little bit longer while we go take the mass of our filter paper. Here's my filter paper. Not very heavy. Okay, so there's our third mass. It's really important when you take the mass of your filter paper that you use the exact filter paper you plan on passing your solution through and capturing your solids on, because filter papers do have slight variations in mass, and you don't want that to be an error in your final calculations. Okay, now we are going to fold our filter paper basically into almost like an origami cup and put it into our funnel. So we fold it in half, like that, and then we fold it into quarters, like that. Now you'll notice at this end you've got 4 flaps of paper. We're going to divide it 3 to one side and 1 to the other to make essentially a little cup that we can seat right into our funnel. Now it wants to pop up right now because it's dry, so I'm actually just going to try to do that a little bit better. And then what I'm going to do here, I am going to wet with a little bit of my distilled water. And once it's wet, it should actually stick a little bit better and hopefully pop up a little less. And this will also help making sure that none of your solution actually passes through or passes underneath the filter paper. It all goes through the filter paper instead, because it's all stuck to the glass, so it won't go underneath. Now, while that's finishing draining there, we'll look at the solution as it's finished. So you can see the color's not quite so brilliant blue, and hopefully you can actually see in that bottom there, the iron, it's taken on this kind of reddish hue. Right? I worked really hard when I was actually stirring that to make sure that I broke up all of that steel wool. It's pretty fine grain anyway, so it exposes its surface area pretty well to the copper sulfate so that it will react fully. But then I also made sure to break it up, and it's pretty much all turned kind of orange. All right. Now we're going to go ahead and filter this. So what we're going to do, we're just going to pour this into our funnel. We want to make sure that the level of the liquid never goes above the level of the filter paper. So only fill it halfway, no more than that. Get that little drop of liquid off there. I want to stir a little bit too. Make sure we get some of that iron in there as it drains through. Bit much there, but it's okay. Use my spatula to try to scrape some of this out. Get it in there. And then what I can do is actually use my little bit of distilled water and wash the sides and try to get the rest of it in there as well. We want as much of this remaining solid in there as we can. Gonna do the best that we can. Actually did a pretty good job. Still got a little bit of solid left down in the bottom, so we'll get that last little bit. And I'm just stirring to try to make sure that it is suspended in that water before I pour it through. I'm going to let a little bit more of the water drain out, so I don't splash too much when I pour this in. Okay. We're going to call that good. Now, we're just going to let the rest of that liquid actually drain through the filter paper. And then we're going to transfer that filter paper someplace where it can dry. And we'll leave it overnight. All right, so it seems to have drained fully now. Let's see if you can see what's inside. That's my solid that's left over. What I'm going to do is take a pair of tweezers, basically, and try to scrape this, pry it off the sides. It's wet, so it wants to stick, and I don't want to rip it. Okay, so just carefully pull that up, and I'm going to put it onto a clean watch glass. This is just a little glass dish that we can hold it on so it doesn't sit on the lab bench, and we're just going to let it dry overnight. So it's been several days, and our filter paper, our product, is now completely dry. You can see that nice, beautiful kind of brownish red color in there. And we are just going to take our last mass that we need for this lab. It's the filter paper plus whatever dried product we captured on it. So we'll put that onto our balanced pan. Okay, so hopefully you can read what that says. It is 1.57 grams. Now you have all the data you need to be able to do your calculations for this lab.